right, guys. So this is your study guide for exam 10. This is the last test you have to take in here until the actual final. So for this video, I have a copy of your study guide with me, and I am just going to go through this and run through it, and hopefully it will answer most of the questions that you might have. So the first page has a differential equation, and as I kind of said in class, the one on your test Friday will be more like the potato question. But that said, if you are looking for extra practice with differential equations, we can look at how this would work. So if we want a tangent line at 1, 0, we should be making a box and listing our point out at 1, 0. And to find our slope, we should plug that point into the derivative, which was already provided to us. If we put in 0 for y, that's going to be e to the 0. And if we put a 1 into these, that's 3 minus 6, which is negative 3. So e to the 0 is 1. So that would produce a slope of negative 3. So then this would be y minus 0 is equal to negative 3x minus 1. That would be our tangent line. And then this asks us to plug in 1.2 to that. So y, I'm going to drop the minus 0. Y is equal to negative 3 times 1.2 minus 1. We could make that a little better. This is 1.2 minus 1 is 0.2. 0.2 is like saying 2/10, and 2/10 is really the same as saying 1/5. So something about negative 3/5 or negative 0.6 would probably be most accurate. But that's how part A would work. For part B, we're finding the particular solution. Anytime you hear that wording, that's our separation of variables. So let me copy it down. We have dy dx is equal to e to the y 3x squared minus 6x. Okay, so we got to get the y terms to the left. Hopefully that makes sense to say. This would be 1 over e to the y dy is equal to 3x squared minus 6x dx. And we want to integrate both sides. So as I always say in class, we want to make sure both sides are ready to integrate before we do that. The right side looks ready to go. On the left side, that is really e to the negative y dy, if we flipped it upstairs, is equal to 3x squared minus 6x dx. Nothing changes over there. To integrate this, you have to do u substitution, u du dy. Okay, so our u is going to be negative y. So that would make du negative 1 dy. So dy is negative du. Okay, plugging that in, this would be e to the u. Now we have a negative sign in front of our du, so I'm going to throw that out front, is equal to, nothing has changed on the right side. And we are now ready to integrate both sides. If you integrate e to the u, that is just e to the u. So this is negative e to the u, but we're going to replace that. So negative e to the negative y is equal to, if we integrate this, this would be 3x to the third over 3. So that's x to the third minus 6x squared over 2. So that would be 3x squared. And then, of course, plus c. Okay, and it's through this point, 1, 0. So we are going to be plugging that in. So this would be negative e to the 0 is equal to 1 minus 3 plus c. That would be negative 1 is equal to negative 2 plus c. Add the negative 2 over. That would tell us that c is equal to 1. So we are going to go back and plug that in. In doing so, that would now be negative e to the negative y is equal to x to the third minus 3x squared plus 1. We are trying to solve for y. The first thing I'm going to do is get rid of this negative symbol. So we are going to divide both sides by negative 1. Okay, we want to unlock this y that's currently the exponent of e. And the trick for doing that is we want to natural log both sides. If we ln the left, the rule is natural log of e to the stuff results in the stuff. So that gives us negative y is equal to natural log. And then our last step is to divide both sides by -1. So y is equal to negative sign natural log of the same stuff. And that would be your final answer. Okay. So feel free to pause and rewind if you want to go through anything else on that one. Okay, next up, we've done this in class. This is the potato question. So this is very similar to the one you will be seeing on your exam. Things to note that we have dH dt is given to us. And I've always been telling you guys from the beginning, when we're doing these, we should be making a key. We're used to seeing dy dx. And in this case, this is going to be equal to dH dt, where H is going to stand for the temperature and T is going to stand for the time. So the first thing you should be doing is making a key so you can kind of see what stands for what. Okay, in part A, it asks us to write the equation for the tangent line to the graph of H at T is equal to 0. Well, up here in the problem, it tells us that H of 0 is 91. So that means at time equals 0, H of T, at time equals 0, the corresponding temperature is 91. So for part A, you would have just had to make a box. I'm going to save space down below for part C. And our point would be 0 for T and 91 for the temperature H. And then to figure out the slope, you would go up right here to the derivative, and we would be plugging in 91 for H. And when you do that, it should result in -16. And then finding your tangent line, this would be y minus 91 is equal to -16 t minus 0. It then asked you to use this equation to approximate the temperature at T equals 3. That means to put a 3. Oops, sorry, this shouldn't be y. That should be what? It should be h, because this is dH dt. So make sure we're careful with our letters. And we're going to put in a 3 for t. And when you do that, the -16 times 3 and then add the 91 over, your temperature would be 43 degrees Celsius. Okay, in part B, it's asking us to find the second derivative. So the first thing I'm going to do that is we're going to clean up the first derivative by distributing. So we should be able to say that dH dt is equal to -1/4 h plus 27 over 4. This is our first derivative. So to take the second derivative, that's a constant, that's out of there. And -1/4 h, if we take that derivative, we could say that d2h dt squared is equal to -1/4. And then this is implicit, so it's dH dt. As a reminder why that is, we just took the derivative of the letter H, but the bottom right-hand letter is what it's with respect to is a T. When those two letters aren't the same, you have to d whatever dt it, in this case, dH dt it, and that's what we're going to tack on. Now, we know that dH dt is this expression right here. So this is going to be -1/4 times dH dt, which is -1/4 h plus 27 over 4. And then we can do a little bit of distributing, and this would work itself out to h over 16 minus 27 over 16. So this is what we're going with for a second derivative. And then it says, is this an over or an underestimate at t equals 3? Excuse me. So what do we know about t equals 3? The temperature would be, we found in part A, that temperature would be 43. So if I put a 43 in for H, this result, 43 minus 27, it's going to be a positive answer. So since the second derivative is greater than 0, we would say therefore concave up. Therefore, what's our story? If something is concave up, all of the tangent lines would lie below it. So therefore, underestimate. Okay. And that would take care of part B. All right. For part C, we are using this new format, dg dt, and we want to separate the variables and do all of our stuff. So just like before, we should make a key. So we're used to dy dx, that then turned to dh dt, but now we're on to dg dt, where the g stands for temperature and the t is at our time. So to split these, we would move this one downstairs, and that would be 1 over g minus 27 to the 2/3 dg is equal to -1 dt. Okay, we don't want to, so we'll just call that -1 dt. That's coming from this number right out front. To integrate this, the right side is ready, but the left side needs u substitution. So we're going to go u du dg. So g minus 27, the derivative of g minus 27 would just be 1 dg. So if u is dg, dg must be du. Okay, so this is now 1 over u to the 2/3 du, and then -1 dt. Okay. You might be tempted to try natural log, but remember that only works with 1 over x, 1 over y, 1 over u. It's got to be only a variable. When it has an exponent, we just flip that upstairs. So this is u to the -2/3 du is equal to -1 dt. Okay, we are finally ready to integrate. So this would be u to the 1/3 divided by 1/3, but hopefully that makes sense. Divide by 1/3 is multiplied by 3. So 3u to the 1/3 is equal to -t plus c. We should plug in for the letter u. So this is 3g minus 27 to the 1/3 is equal to -t plus c. And then if you go up to part C, you will see that the point they've provided you is 0 for T and 91 for G. So if I put 91 in for G and 0 in for T, 91 minus 27 is 64. The cube root of 64 is 4 times 3 is 12. So that is telling us that C is equal to 12. Back to the top to get some more room. This would then be 3g minus 27 to the 1/3 is equal to -t plus 12. All right, we're trying to solve for g, right? So we're going to have the expression that we had, divide it by 3. We're going to cube both sides, and we would add 27. So hopefully algebraically those steps make sense. And now we have solved for g. And finally, it asks us to plug in 3 for T. What is the temperature at 3? So G would be equal to, if we put a 3 in here, -3 plus 12 is 9. 9 over 3 is 3. 3 to the 3rd is 27, and 27 plus 27 is 54 degrees Celsius at T is equal to 3. And again, of course, feel free to pause and rewind if you would like to go back over that. All right, when we're looking at volume. All right, so what's the story here? Find the volume when this is revolved around the x-axis. So we don't quite have a picture of this, but hopefully it makes sense to say that we are used to saying volume is equal to the integral of the area of the cross section, AOCS, area of the cross section. And the area of the cross section, when we're revolving it around the x-axis, is going to be in the shape of a circle. And we said that the radius is always going to be the function value. So the first thing we want to do is figure out what is the radius, and the radius in this case would be radical sine x. So when we go and set this up, it's going to be volume is equal to, we're trying to set up pi r squared. So pi and then r squared, we're going from 0 to pi. The radius is root sine x, and then we are going to square that. So pi r squared. Now we have a setup. So volume is equal to pi. When you square that, that just leaves you with sine. And now we're ready to integrate. The integral of sine is negative cosine. So this is pi, and then I'm just going to leave that on the outside. And this is negative cosine x from 0 to pi. Okay, so that's going to be pi times negative cosine pi minus negative cosine 0. I think it's in your best interest to write this all out, just because it's so easy to miss a negative sign and this and that. Like, it's easier. I'm sure you can do it in your head. I think it's just more likely to avoid silly mistakes by writing it out. So this is pi. All right, what do we got here? Cosine of pi is -1, and then negative negative makes that a positive. And on the other side here, we've got cosine of that is 1. This makes it -1, but minus a negative makes it a positive. I am coming up with 2 pi for an answer there. And again, that was because cosine of pi is -1, but this negative makes it positive. Same story here with the double negative. So the pi then gets multiplied by the number 2. And that's our final answer. Okay, for this one, I will go over the answer, but this is not on your test. So this is y-axis setup. Could you see one of these on the AP exam? Definitely. So as kind of a visual, what do we have here? We've got two things. We've got y equals x would be kind of that one. And then y equals 3x, same idea, but that should be a steeper slope, since it's like 3 over 1. Sorry, I'm going to find a different color to write with here. Let's see if we can separate these. Okay, there we go. So, and it says that we're going to do this from y equals 0 to y equals 5. So the gist of what we're doing is that these are going to get revolved around the y. And when you do that, that goes back to that picture I kind of described as the tornado, or a bowl, whatever you want to think of it as. So we have something that kind of looks like that. And what's the gist here is that it's the volume of the outside minus the volume of the inside. Now, in order to do this, you've got to solve both equations to be in terms of x. Now, the first one's easy enough. If y is equal to x, that means x is equal to y. And that is which function? Y equals X. This was the outer function. And then the inner function, if we solve that one out for X, X is equal to divide by 3. So that would be 1/3 Y. And that's the red one. That is our inner function. Okay, so we are revolving these guys around the y-axis. So it's going to be with respect to y. So this would be pi, bounds are 0 to 5, pi r squared dy minus pi r squared dy. And that is our setup. So from there, you just have to crank out the math. But the setup is pi r squared minus pi r squared, outer one minus the inner one. And that is all equal to volume. So that would be our setup. If you chose to keep going, then we would just have to do a bunch of math. So 0 to 5, this would be y squared dy minus pi 0 to 5. We square this. Hopefully it makes sense to say we've got y squared over 9, or you could call it 1/9 y squared, however you want to write that. Okay, so if we integrate these, what are we going to come up with? This would be pi, and then what do we got here? Y to the third over 3. And the other one is going to be y to the third over 3, but there's a 9 down there. So that's going to be y to the third over 27. Okay, so plugging into this is going to give us 5 to the third. 5 times 5 times 5. That's what, 125 over 3. And this one over here, it looks like it's going to be 125 pi over 27. And looks like we would need to common denominator, so triple these. That would be what, 375 over 27. And that's 250 over 27. Looks like these are divisible by some stuff. So it looks like divisible by 3 would take us to, wait, no, I'm lying. That's not divisible by 3. Might be final answer right there. So double check the math, make sure that's all correct. I'm going kind of quick here. The premise here is we want to make sure we're going with the outer function minus the inner function, and that would be our setup. So again, feel free to go back to that if you have questions. Okay, this page looks much more representative of what you will see on your test. So for this one, we want to find the area. So we have two shapes. We have this one and we have this one. So if we want to find area, area is just a 2D calculation. That's going to be the integral of the top minus the integral of the bottom. So that is the integral of 6 minus the integral of 2 root x. And we're going to write that as 2x to the half just to get that in integration form. And then I'm going to combine these and say this is 6 minus 2x to the half. And then from there, we are ready to integrate. So this would be 6x minus, and now careful here, what's going on here whenever we do this? This would be 2x to the 3/2 over 3/2. And then divide by 3/2 really means to multiply by 2/3. So 2/3 times 2 is 4/3. And then x to the 3/2. Bounds are 0 and 4. 0 is not going to be helpful here, so we only have to put in a 4. So that is going to be 24 minus, if we put a 4 in there, that goes to 2 to 8. That would become 32 over 3. we would need to transform this to be 72 over 3 minus the 32 over 3 should give us 40 over 3. Okay. All right, when we're finding the volume, okay, we got to be careful here because we have two equations. So this goes back to the washer idea. And when we do that, it's going to be the outer minus the inner. So when we find the volume of region A, we're going to say volume is equal to the outer function. So when we're doing this, this is really bringing both of these the other direction. So you would have this one down here, and then that one would curve up. So the outer function is the horizontal line. So the outer function is pi function and then pi r squared. So pi, and what's our function in this case? It's just going to be 6 squared. And then minus pi, and then function squared is going to be 2 root x squared. Okay. So that's our setup. And then after that, you just have math to do. So volume is equal to pi, and then this is going to be from 0 to 4. Let's combine this and say it's 36 minus 4x. 36 is 6 squared, and 2 root x times 2 root x is 4x. If you integrate that, this would be pi 36x minus 2x squared. In case you're not following, that would be 4x squared over 2. 4x squared over 2 is 2x squared. Put the 4 in, and this would become 144 minus, what are we doing there? 32. And if we take that away, that would be 112 pi. Okay. Set up but do not solve. A formula for the volume when region A is revolved around y equals 8. So we make a little visual on this to the best we can. Here's this. It goes from 0 to 4. This is up to 6. And at 8, we want to now have this new line that we are revolving around. So if we draw this symmetrically, that's a gap of 2, and that would be a gap of 6. So we would have something that would look like that. When you revolve these, you've got two functions that are revolving. So we've got to figure out what the story is for both of them. So one of these, the cross section is this one. That's the outer piece, but then also we have the inner piece. So we need to locate both of these, and it's going to be outer minus inner. So for this outer circle, we got to figure out a way to express the radius, right? So we want this radius right here. And the math behind that is if you just integrated the number 8, that would give you that red line. And if you just integrate this function, it gives you that piece right there. So to come up with the radius, it's red minus the function. And red is the number 8. So we're going to say volume is equal to, we're going from 0 to 4. Of course, we need our pi out front, and it's going to be 8 minus the function value squared. So that's our outer function, pi r squared dx. Outer minus inner. So now to come up with this one, this would be same idea. To get that, it's going to be 8 minus the function. But in this case, the function is just the horizontal number 6. So as far as I'm concerned, you could leave your answer just like that. Also, making that 2 would make sense because that's a pretty easy calculation. But in general, that would be setting up but not solving. Okay. So for some of these now, I don't have a calculator sitting beside me. So we're just going to discuss the idea. And obviously you could then plug these into the calculator on your own time. This question talked about, this was an in and out question. So R of T stood for in. We were told that 0.7 people per second are leaving. That's our out. And there's 20 people at the beginning of the story. That's our IC, our initial condition. Okay, so how many? How many? That is a total amount. How many people enter the line from 0 to 300? So you should be writing the integral from 0 to 300 for R of t dt. You put that into a calculator, and I believe the answer comes out to be 270 people. For part B, how many total people are in line? Total. This sounds like a total amount, which means we need to make an amount formula. So the amount formula for this would be 20 plus the integral from 0 to 300 of R of t dt, which we just figured that out in part A, minus the integral from 0 to 300 of 0.7. That's the rate at which people are leaving. So then this would give you 20 plus 270 minus, you can use a calculator for this or just do it by hand. That would turn to 0.7x or 0.7t rather. Plug in your 300, you're taking away 210. That tells us that there are 80 people left after the 300 seconds. Okay, for t is greater than 0, at what time are there no people left in line? Well, if there's 80 people left, you would divide that by 0.7, and that tells you how long it would take to get rid of the remaining people, and it was 114 point something. Now, the total time, though, remember, there were still 300 seconds that went off in this story. So we had 300 seconds go. And then after that, it's going to take an additional 114 point whatever. So a grand total of 414 point whatever seconds is when there would be no people left in the line. Okay, for part D, at what time is the number of people in line a minimum? So this is our absolute minimum. So we're going to be going with 0 and 300. And now we should already know these two, right? At 0, there was 20 people, and at 300, we already know there's 80. We figured both of those out. What's the story? We need a critical points. And what are we finding? The amount. So I need a prime of t. So a prime of t is just going to be r of t minus 0.7. That's taking the derivative of this amount formula. The 20's gone, this integral's gone, that integral's gone. So that's where I'm coming up with r of t minus 0.7. And then you need to graph this in a calculator and see where this is equal to 7. Or excuse me, where this is equal to 0. I was looking at the 7, sorry. Where your critical point would pop up is when this is 0. Alternate way to think of this. So it's either graph this and figure out where it's 0, or you can also say algebraically, that's equal to this. So if you go this route, you would find the 0. If you go this route, we would find the intersection. Either way, there's two more numbers that would pop up. Critical point, you would figure out those critical points. Now, once you figure out those critical points, you would come to this amount formula right here, and you would plug them in as the top bound. So this one and this one are no longer going to be 300. That's going to be whatever critical point we have come up with for each of these. And then you've got a new y value and a new y value. And whatever the smallest y value is your answer. If I remember right, it's like 3 point something. It rounds to 4 people. You guys can look this up. This is from 2020 AP Calc exam. But that's the gist of how this problem would work. So we've done all the Joanna jog stuff, and I told you in class that this one, we definitely want to make sure you know how to do part A. So to do part A, you're estimating the slope 16 lands right between these two. So this would be 240 minus 200 over 20 minus 12 That's 5 meters per minute squared. The problem you're going to see tomorrow, as we said in class, it involves this table of data, but instead of running, this is going to be our out formula. And then you're going to have, it's going to be your in and your out question. For in, you're going to have a formula given, and then there's also an initial condition given. So to figure out the total amount formula for this question, A of t, is going to be equal to the initial condition plus the integral of the in formula from whatever to whatever bounds minus, now, let's just say, for example, let's say that this out formula is whatever, O of t for out. We're still going to express it as the integral of this. But since the out formula is going to be table stuff, it's going to tell you something like use a Wright-Riemann sum to approximate the out or the amount of water that drains or whatever it's talking about. So to do this, you're going to have initial condition. This is going to be done in the calculator, and this one is going to be a Riemann sum. And then outside of that, everything else in the question should all follow suit in terms of what you're going to be looking for. For particle motion, I mean, we should hopefully be very familiar with this. Your study guide has all of this written out. So for speeding up or slowing down, this is when you would compare V of 4 to A of 4. This is going to be found in the calculator. We would want to graph this. And then to find A of 4, it's either going to be the slope of the V of t graph, or do math 8 and take the derivative of your velocity, and that will tell you the acceleration. Part B, when does it change directions? It changes directions whenever the velocity crosses the x-axis. Make sure you're paying attention to the window of said problems. C, find the position of the particle at t equals 0. To find position, we are going to integrate the velocity from a bound we know and a bound we want. It asks us at 0, and up here, that statement, x at time 4, that's like saying x of 4 is equal to 2. So the top bound here is going to be 4. So that is x of 4 minus x of 0. And we know x of 4 is equal to 2. So now we have x of 0, slide that to the left, is equal to 2 minus the integral from 0 to 4 of v of t dt. You would type that into a calculator and get an answer. Part D, total distance traveled. We got to know that formula, the integral of the absolute value of v of t dt, in this case from 0 to 3. So feel free to pause this and try these in the calculator, but that should take care of all of those. So we looked at most of this in class. If we want to find the value C, this is MVT. We should make a graph, make a curve, and then what do we got? From 0 to pi. If we plug those in, that's 0 and 0, which means the slope is going to be 0. So we should take the derivative, which is cosine x, and set it to 0, and that produces pi over 2 and 3 pi over 2, but I'm going to scratch that out because only pi over 2 would fit in that interval. Okay, area bounded. How do we do area bounded? Integral of the top minus bottom. If you plug 0 into this, hopefully we would see that this one's on top and that one's on the bottom. So this would be the integral from 0 to 2 of 2x plus 1 minus the integral from 0 to 2 of negative x dx. And I think we've done more than enough integration in this video and or in general that you should be able to figure that out on your own. That would be the setup, and then you would go through and do that math. Find the average velocity. Average anything is 1 over b minus a. So 1 over 2 minus 0, so just 1 over 2. 0 to 2, and then this is 3, and then 4t plus 1 dt. This looks like we need some u substitution involved, so this would be u du dt. So we've got 4t plus 1. So that's 4 dt. So dt is du over 4. So that's 1/2. Now, what does that produce? 3 u to the half du over 4. So this 3 is coming on the top and this 4 is headed on the bottom. So this is going to be 3/8 out front, 0 to 2 u to the half du. Integrate this and we've got 3/8 u to the 3/2 over 3/2. That's really multiplying by 2/3. 2/3 would make 6 over 24 u to the 3/2. That's 1/4 u to the 3/2, and we have bounds from 0 to 2. So careful here because this 0 is relevant now. So if we put 2 into this, that's going to be 8, and one more makes 9. So that's 9 to the 3/2. And then when we go the other way, we put 0 in, that makes 1 to the 3/2. Okay, square root of 9 is 3. 3 to the third is 27 over 4 minus 1 over 4. I'm getting 26 over 4 or 13 over 2. All right, so we're starting to get into some repeat stuff here. G equals integral f. This has been all over previous tests, so hopefully we're good with these. Make sure we know that our first statement when you're answering these, though, is since g prime of x is equal to f of x, find the absolute max and min on -2, 10. So you should have a table with -2, 2, 6, and 10, and you would plug those into the top bound. These would all result in areas. Find the equation to the tangent line. So what do we know? At x equals 0, so the point would be 0, comma. If you plug 0 in, that results in 0. And then how do we find this slope? Well, we know that g equals integral f. So g prime of x is equal to f of x. So g prime of 0 is equal to f of 0. And this is the graph of f. So f of 0 is -2. And now you've got your stuff there. Excuse me. Additionally, with this question, we talked in class, if you see something that looks like this, and we say that this is a half circle. So if during your adventures tomorrow on a problem like this, you had this, and we needed to find that area, this being 4 over 2 up. So we said you had to make a box, and this box would have an area of 8. So that's 8 minus, and then we're going to subtract this half circle, and that half circle is going to be pi r squared, but then cut in half. So that would be 2 pi. So for the example that I just listed here, this shaded area underneath is 8 minus the half circle. So 8 minus 2 pi. And that takes care of that. Let's see here. I don't think there's a whole lot left we would need to do here. Find all POIs. So make sure we're careful here. When you take the derivative of the integral, you just get the same thing. And then you would take the second derivative from there, set it to 0, go find your stuff. When you're doing these, make sure you make a picture and then be careful. The big bound must be on the top. So like this one's good, but this one is really 9 to 3 f of x dx is going to be equal to -5 because we got to change that symbol with a negative. And then when you go to find these things, this is, you're going to split them up. So it's 5 to 9 f of x plus the integral from 5 to 9 of just the number 1. And then you would integrate each piece. This is just going to be area. And this one you would turn to x from 5 to 9, plug in your stuff, and go from there. Did this one in class already. We should have that in our notes. This one you integrate, but it turns to plus c. So this is 5x to the third over 3 minus 3x squared over 2 plus c. That's now f of x. But then when you use this condition, this tells me if I plug in 0, I get 1. It means c has to be equal to 1. And then now that you know that that's 1, to find that, you would plug 1 into what's left. That we know how to do. That's the definition of our derivative. Top right corner, derive it, plug in pi over 4. Derivative of tangent is secant squared, going from there. And the last page, all pretty straightforward stuff. This one is going to be where we split it. So this is x squared over x to the third plus x over x to the third. So this is going to be 1 over x plus 1 over x squared. That one's natural log. This one you would flip upstairs to be x to the -2, and then you would integrate it from there. We've done a million of these. This is going to be u substitution. We should know how to do that. So this is the one where you plug in, to take this derivative, you have to rewrite it. And we're going to chain rule this. So the derivative would be 2, keep it, drop it, derive it, something like that. And you would go from there. Absolute min, same story. This is a half circle, but this is not a bad one because this half circle you can just use. You don't have to do anything crazy with that one. In this case, they are giving you the point. So this is FTC integrating from a bound you know to a bound you want. So anytime you set these up, it's going to be the integral of f prime of x dx. One of these bounds we know, one of these bounds we want. You get f of one minus f of the other, and we go through and solve. So that's the whole packet, guys. Hopefully you feel comfortable with that. Feel free to message me questions on Remind if you have any questions, and I will see you guys in class.